welcome back to the lecture series in bioelectrochemistry. So, we are into the second week and today we are into the 7th class, which is essentially the second class of the second week. So, as I told you that we are moving little slow, though this week we are supposed to dealt with different kind of electrodes and the potentiometry, but instead we are still on to the basics. The reason being, like this part, after this we will be talking about Nernst equation. This part is the basic core fundamental of your understanding of electrochemistry, and if this part is clear, then rest will be a much more easier journey for us, and that is why I am extending it. There is a spillover into this next week, but do not worry, I am really pushing it on the fundamentals. So, coming back, let us resume this class. So, if you people remember that there was one question which I posed, that electrochemistry is what kind of science? So, interestingly, electrochemistry is basically a surface science. It is a, you can call it a surface analytical tool, or it is a surface chemistry. It is precisely a chemistry on the surface. It is not on the bulk material, it is all the reactions which are happening on the surface of XYZ metal. Okay. So, when you talk about electrodes, so as I told you, or next week we are supposed to, or the second week was the schedule for electrode. The very fundamental electrode is called the reference electrode or standard hydrogen electrode. In short, they call it SHE. Today, while dealing with our next topic, which is our standard potentials, we will talk about standard hydrogen electrode, and as a matter of fact, that will be our first electrode what we have to understand. And literally at times I always feel when I look back that this one really confused me, and I was always confused that what is this standard hydrogen electrode is all about. So, today we together will explore that, and in that process we will talk about the standard potentials, what we mean by standard potentials. So, before even getting into the class of standard potential and what it meant, I wanted to do a small recall. So, if you remember in the first class we talked about that there are different kind of metals, non-metals, and or different kind of elements, and each one of them have a certain power either to donate electron or to accept electron. So, we have to take one scale. So, say for example, we say each one of them have, we categorize them, each one of them with their power to donate electron or give away electron. In other words, they are getting oxidized. Okay. So, their potential to get oxidized, or we can call it a reverse way, which is generally the convention which is followed. A material or an element or a compound, a potential to accept an electron, in other words, it gets reduced, right. So, we can classify, or we can classify will be a wrong word, essentially we can make an ascending order or a descending order based on who will be able to accept electron. Say for example, I am standing here, 5 other people are standing there, and we all have a different power to grab electron. So, who will be grabbing it faster than the other? You understand? So, based on the power, say I have say this much horsepower, say 10 horsepower, someone has 5 horsepower, someone has 3 horsepower, I can put a categorization saying that okay, he has 10 horsepower, he can drag the electron faster. Okay. So, in other words, one can classify any material based on this unique surface property of accepting electron or giving away electron. And again I told you, you have to follow one scale. You can follow both the scale, but you have to be careful which scale you are. So, you have to give the reference that I am following the oxidation scale or I am following the reduction scale. Okay. So, now if we say that every material has a power to accept electron or to donate an electron, you can classify them. Then in order to develop any kind of scale, whether the based on oxidation or based on reduction, what you will be needing is, what you will be essentially needing is a reference. With respect to what? Because that way only you can classify something. Say for example, just the most easiest example, we call 7 as the neutral pH. So anything less than 7, 6, 5, 4, 3, 2, 1, 0, they are all acidic side, and obviously 2 is more acidic than 6. Similarly, anything more than 7, 8, 9, 10, 11, 12, 13, 14, they are all alkaline. So what we say is 14 is more alkaline as compared to say 8. So there is a scale. So your reference is at 7. So similarly, in electrochemistry or any kind of electrical measurement, you needed a reference, and you have to develop that reference, and that reference is another electrode, and that's what we call as standard electrode. So that will be our learning about the first electrode, and as I mentioned in the assignment that electrochemistry is a surface science or a surface chemistry. So we will talk about those reactions which happen on that standard electrode and how we measure it. So let's start with, so we are into our, with this background. So before I just jot down my points, with this background I wish to start this class that today we will be understanding those basic fundamental electrodes which are useful to decide or draw that chart by virtue of which you can say this X compound has more power to donate electron or more power to accept electron as compared to the Y compound, that whole gradation. Okay. So let us start our, today we are into, one second, okay, lecture 7, or in other words this is week 2. So week 2 lecture 2 essentially it is, okay, which is in sum total this is the 7th lecture we will be dealing with, and the topic we will be dealing with is standard potentials. Before we get into the standard potentials, let's recollect what we, where we ended up the last class. So if you remember the last class we had this cadmium and silver electrode. So you had this cadmium electrode on your left hand, right hand you have the silver electrode, the silver electrode sitting, you have the cadmium electrode sitting, you have the voltmeter, and here is the connector. Okay. So on, so here you have the silver sitting in a solution of AgNO3, one second, because from here we will build up our story. There are a few axioms which I have to tell you which will be very helpful. So you have this cadmium and you have CdNO3, which is the aqueous, and here you have the cadmium solid electrode, Ag electrode, then you have AgNO3 which is in the aqueous form, and you have the salt bridge which is connecting the two. Okay. and the salt bridge had the KNO3, potassium ions which were moving like this, and if you recollect, those potassium ions were leaving this part, and you have the NO3 ions moving inside from the cathode side. This is your cathode, this is your anode, where you are having the oxidation taking place, cathode is where you have the reduction taking place, and this is where we observe that some of the cadmium ions getting inside the salt bridge and some of the NO3 ions coming out from the salt bridge this side. Okay. Here you have the NO3 minus, and this is your salt bridge. More or less this is what we have talked about, and we told that on this cadmium surface we are having the oxidation taking place. This oxidation leads to liberation of electrons. This electron goes on the voltmeter. This is the negative terminal and this is the positive terminal. I will come to this axiom. So, this electron goes to the negative terminal, and on the AG surface where you are having the reduction taking place. So, electron is traveling, essentially this is where you are having the reduction happening on this surface, okay, on the surface of cathode. And if you remember the reaction what we talked about, 2 Ag plus on the aqueous side plus 2 electrons making it 2 Ag solid, silver solid, whereas on the cadmium side you have cadmium which is solid making cadmium 2 plus which is an aqueous. As you could see, the cadmium 2 plus coming into the aqueous solution, whereas in that process it liberates those electrons, and these are the electrons which are getting carried. And in summary, if we follow up in the last class what we talked about, the voltage measured in this figure, this is where you are measuring the voltage. Okay. The voltage measured is the difference of the electric potential between silver electrode on the right and cadmium electrode on the left. Okay. So, basically voltage measured is the difference in electric potential between the silver, okay, electrode that is on your right and the cadmium electrode that is on your left, and cadmium electrode on your left. This is precisely how the configuration is, and voltage tells us that how much work can be done when the electron is flowing from one side to another. This electron flow and this voltage across it tells us how much work, and this will take you to all the basic formulae, okay, can be done, how much work can be done while the electron flowing from one side to the other. While electron flowing from one side to the other, which is essentially your from left side to right side. Okay. This is what we talked about, and there is one more axiom which is very important for you to realize here is this part is very critical. That is why I am putting it in green. Just mark this. Okay, the potentiometer or the voltmeter indicates a positive voltage. This indicates a positive voltage when the electron flows into the negative terminal. Indicates positive voltage when electron flows into the negative terminal. So, there could be a vice versa, and this will come very handy, and please mark this word while we will be talking about the electrodes. And the vice versa, if the electron flows in the other way, say for example, the electron, say for example, suppose the electrons are flowing like this, then the terminal is going to show you a negative voltage. So, keep that in mind. If the electrons are flowing onto the negative terminal of the voltmeter, if the electrons are flowing into the negative terminal of the voltmeter, it will indicate a positive voltage. Reverse, if the electrons are in the reverse direction, means on the negative terminal of the electrode, electrons are not flowing, they are coming from the other direction. Then, so this is all about how you place the potentiometer, which polarity you are following. From the negative terminal, electrons are flowing onto the negative terminal of the potentiometer, then it will show a positive deflection. Remember this. This will come very, very handy as we will move through. Okay. So, keep that in mind, and then from here we will go to the color coding. If we just for your practical interest, whenever you come across any of these things. So, there are certain color coding, so which are being used pretty frequently. So, you will see a black color and a red color on much of these potentiometers when if you look around. So, the negative terminal of a voltmeter is labeled as, sometime it is also labeled as common. This one is also called common, and this is your negative terminal of voltmeter. Okay. Keep this in mind, this may come very handy. Whereas the red terminal is the positive terminal, this is the positive terminal. So, whenever now onward you handle a voltmeter, you should know that if it is a red, it is the positive terminal, and if it is a black, and if it is written common, then it means, so there are two catch, either it will be written common or it will be colored black. So, in that case, this is the negative terminal of the voltmeter. Okay. Keep these two aspects very clearly in mind, and it may be colored black or positive. When, say for example, when you see a socket like this, so I will draw a socket for you guys. So, something like this, you must have seen these kind of sockets all the time, when you use pH meter and all that, you must have seen something like this, a socket you will see, or you will see something like this, a thin connector like this, especially in the pH meter. If you look at the pH meter very carefully, something like this. So, the positive terminal is the wear at the center, the inside the connector. So, in other word, so here your positive is like this out here, and this rim what you see is where the negative is. So, try to realize if sometime you want to do some kind of a trick. So, is the center which is the positive and the outer periphery is the negative. Okay. Similarly, if you look at these older style ones, which is mostly you see in devices imported from US, you will observe this one, there is an additional thin stuff like, you know. So, these pH meters, this is called the reference or negative terminal, and the pH is on the positive terminal. So, this is the positive terminal, which is pH positive terminal. Okay. So, this is basically, you will see all the instruments, pH instruments or something, if they are imported from US, you will observe this. And when a pH meter with a BNC socket is used, the potentiometer, the center of the wire is the positive input as I showed you, and the outer connection is the negative output. So, this is basically we are talking about the BNC cable. So, all the standard BNC cables are like that. So, keep that in mind. So, these are some of those I can say some of those practical knowledge what I wanted to put forward. So, the first thing what I put forward is about the voltmeter. Whenever you look at the voltmeter, so it could have a positive and a negative terminal. Okay. So, if the electrons are reaching the negative, if the electrons are reaching the negative terminals, then it will show a positive deflection. If electrons are reaching its positive terminal, it will show a negative deflection. This is the first thing what you have to learn. And the second thing is, some of these BNC cables, whenever you use, you should know that which terminal is what. So, the center of these BNC cables will be positive and the outer periphery will be negative. So, I will stop here, and the next class we will, with this background, we will move on to the next lecture, where we will be talking about the standard potentials with this background in mind. Okay. Especially, please do remember the axiom on the potentiometer or voltmeter. Okay. Thank you.